Hello everyone, my name is Ayush Mishra and I am from MSP 3rd year IIT Roorkee. The topic of this presentation is Bourdon type pressure gauge. A Bourdon type pressure gauge is a mechanical device used to measure the pressure of gases and liquids. It was invented by a French engineer Eugene Bourdon in 1849. Bourdon type pressure gauges are widely used in industrial and commercial applications. The basic construction of a Bourdon type pressure gauge is as follows. This is the fixed end through which pressure is applied. This here is the free end, which basically translates the movement of the tube to the dial. This here is the linkage mechanism which connects these two elements. How does Bourdon pressure gauge work? The Bourdon tube is the primary sensing element in the pressure gauge. It is a curved tube that is flattened in the cross section and has a fixed end and a free end. The free end of the tube is sealed and connected to the pressure source. When the pressure inside the tube increases, the tube tends to straighten out, which causes the free end of the tube to move. This movement is transmitted to the pointer through a linkage mechanism which indicates the pressure on the gauge field. Gauge dial. So as you can see that the tube is hollow. This is the fixed end through which pressure is applied, and then when the pressure is applied, this C-type tube flattens out, and this movement of the free end is translated with the help of a linkage mechanism to the dial. This is a graphical representation of the working principle. Advantages. Bourdon type pressure gauges can measure a wider range of pressure than diaphragm and bellows based pressure gauges. They can measure pressures up to 10,000 psi, while diaphragm and bellows based gauges are typically limited to pressure below 1,000 psi. Bourdon type pressure gauges are generally more accurate than their counterparts. They are less affected by changes in temperature and they have a more consistent response to pressure changes. Bourdon type pressure gauges are generally more durable than diaphragm and bellows based pressure gauges. They are also less susceptible to damage from shock and vibrations, and they have fewer moving parts that can wear over time. Also, they are relatively inexpensive and they can be used in hazardous environments. Disadvantages. They can be affected by temperature changes which can cause errors in measurement. They are not suitable for measuring pressures in very viscous fluids or fluids with high solid content. They require periodic calibration to ensure accuracy. The two errors that needs calibration are zero error and multiplication error. It should be noted that there is no one particular type of pressure gauge which is universally more accurate and reliable than other types. It depends on the type of environment in which the measurements are to be made. However, more generally, when the environment is more chaotic, which means the environment is not exactly stable and the temperature conditions are varying, then Bourdon type pressure gauges can be preferred over bellows type and diaphragm based pressure gauges. Dealing with zero and multiplication errors. As you can see from the graphs, zero error is a type of constant error which is present in all of the readings taken and it is of the same magnitude. Multiplication error, on the other hand, is like an error in the multiplicative factor of the measurements. So the blue line represents the actual measurements, the actual value of the pressure, and the orange line represents the measured pressure, and as you can see that the slope of the orange line is different from the input pressure line. By definition, multiplication error is the error when the total movement of the mechanism does not equal the total change in input. Zero error is the error of the same amount and in the same direction through the entire pressure range regardless of the input pressure. To explain zero error with an example, when we apply 0 psi, the gauge indicates 10 psi value. When we apply 50 psi, the gauge indicates 60 psi. So basically, the error in the measurement is 10 psi regardless of the input pressure. Explaining multiplication error with an example, when we are applying 0 psi, the gauge indicates 10 psi. When we apply 50 psi, the measured value is 50 psi, which is represented by this point of intersection in the graph. When we put a pressure of 100 psi, we get the value of 90 psi. To calibrate the pressure gauge and eradicate the zero and multiplicative error, we can use the following arrangements. Zero error can be corrected by repositioning the pointer on the shaft or by changing the tension in the spring. So, for example, when we don't apply any pressure and the dial still reads 20 psi, we will have to backward the pointer by 20 divisions. Multiplication error is corrected by changing the length of the levers. Applications. Bourdon type pressure gauges are used in a variety of applications, including monitoring the pressure of gases and liquids in pipelines, tanks, and other vessels, measuring the pressure of steam in boilers and other industrial equipment, measuring the pressure of compressed air and other gases in pneumatic system, monitoring the pressure of hydraulic fluids in hydraulic systems. Conclusion. Bourdon type pressure gauges are a reliable and accurate method of measuring pressure in industrial and commercial applications. They are widely used due to their versatility, ease of use, and low cost. However, they require periodic calibration and can be affected by temperature changes, shock, and vibration. Thank you.